Hello. I know I'm between you and lunch, and some of you have seen this before, but this is was supposed to be Brooklyn Zelenka, so you get the slightly more high-level version from me, Boris Mann, founder and CEO of Fission. So what Fission does is we are a protocol-first applied research and implementation team. As you've heard from some other talks, we've been doing a lot of work doing protocol-first development and working with lots of great partners like Web3 storage in designing these systems so that they can be used for all sorts of things, but then interoperate. So we're well known for the protocols that we've been working on over the last couple of years. An edge computing stack with cute characters, the UCAN, Toucan, Winnie, the WinFS cat, our encrypted file system, and this talk is about IPVM, and that's the Homestar Toucan. Please don't ask why the star is upside down. We've been really happy to see the widespread adoption of UCAN and WinFS across the PL ecosystem and beyond. We see that protocol layer being a public good. It's the thing that lets us build larger systems that people can go different directions, build apps, build protocols, build commercial services, build open and commons networks, tie into other Web3 ecosystems. IPFS has this unique capability to connect, I know it's the name of the conference, all of Web3 because it's the part at the edge that talks to everybody else and it talks to the user. So the Interplanetary Virtual Machine, or IPVM, a little background from Brooklyn. So to date, IPFS has been a project focused on data. It's a specification for bringing content address execution to content addressed data. To this end, the spec aims to be the easiest, fastest, most secure, and open way to run decentralized compute jobs everywhere. These are the sorts of goals we need to set ourselves. We can't just stop and say, we'll make things slightly better and be centralized. So we always have to be going down this path. And Hannah's talk does an amazing, amazing job of laying the groundwork of why and how this is so super important. So the sort of like more pitchy sort of way, and this is pitching a protocol, not a singular product, is that IPVM should be an open, decentralized, and local first competitor to AWS Lambda. What? How can you just sit there and say that you're going to take on AWS? Aha, because I'm not taking it on by myself. I'm making a protocol that many people can take paths and ideally interoperate and build large open systems together, which can, in aggregate, in fact, be larger than any one of the hypercloud providers. There are many excellent deep dive technical talks that range from half hour to an hour of really dense material by Zishan Lakhani and Brooklyn Zelenka, who have been the main two applied researchers on the project at github.com/IPVM-WG for working group. And it was co-developed with folks at Bacalhau and the FVM to align on the things that we would need in the future. So check that out. So Homestar is the IPVM implementation that Fission has been working on. We've learned from the IPFS ecosystem and tried to go straight to a protocol-first approach where we have multiple implementations that people can get started with. Fission's focus with Homestar is it's written in Rust and it's focused on WebAssembly functions. As an example, Bacalhau is focused on Docker jobs. It's got a libp2p-based networking layer built in. It works alongside Kubo and other IPFS implementations and creates a network of computation. I literally just added this. Super great that Alan talked about this. So just like Web3 storage store add, Homestar computation has receipts. So this is the part where we start understanding, oh, these things fit together, right? Effectively, the Web3 storage system has computation built in. It invokes, does a UCAN invocation, and does these little compute jobs specific to their system. And it can compose, so we don't have to be tightly integrated in their system, but you can have a workflow that kicks out and does a Web3 storage job. So in Homestar, in IPVM, the protocol, if a workflow or task is being computed, the receipt has the value that you can just fetch from the network. So gossip subbed over libp2p. So any of these Homestar nodes that are connected together or have the content addresses on some content addressable store you can check to see if it has already been computed and just fetched it. And that's that UCAN invocation spec. Yes, it's specs all the way up and down. So the Everywhere Computer is Fission's platform to support a protocol. And ultimately, this is the work that the IPFS and Filecoin ecosystem has been doing a flurry of specs, getting them working at all, and then climbing the path towards productization, either inside a team or seeing it spread between other teams taking both open source and commercial approaches to things. So the Everywhere Computer, lots of people have platforms. The Everywhere Computer is Fission's. It's a branded and supported distribution that bundles Homestar, a control panel, a function workflow marketplace, and managed compute resources. As a developer, you write functions and integrate custom services. As a user, bring your own compute or rent hours. As a computation provider, bring custom resources and register them with the network. And there's lots of interesting stuff. I've already had discussions with someone who's building GPU-heavy compute. And I said, absolutely, we would have a profile for running a Homestar node that would advertise that that node has hefty GPU resources. Some of the IPVM functions running in a low-end Android phone would obviously say like, I don't have a lot of GPU. Can I farm this out to someone who has? And then as an on or off-chain ecosystem, federate your own network with the function, services, and resources that matter to you. So in the Web3 space, there's been a lot of discussion about application-specific blockchains. And we've got roll-ups and layers and all of these other things like that. And those can be very customized. Some of those things you're going to run as on-chain smart contracts, which are very expensive and consensus important. And other things you're going to want to have more storage, more massive compute off-chain. So one can imagine applications where you have a set of functions. You know which functions your application needs. They can be broken up into small pieces of computation. You could stake on-chain for those functions. You could make everyone keep them around. You can have a type of IPFS desktop type thing, except it does computation that run backends as a team together. And those are some of the directions we see going with the Everywhere Computer. So we've seen proprietary platforms start with generous freemium plans and then start targeting an enterprise market and really squeeze entry-level plans. So my evil plan is that the great integrated DX of a Vercel, a Netfly, or Heroku in days gone by, all of those systems are platforms that are not open source. They have a number of different capabilities around data, identity, data, and compute. If you outgrow those platforms, you have no choice but to essentially rewrite from scratch. If a developer starts on those systems and then hits up the edges and goes, I can't afford this much, they have no other options. They throw out their entire platform investment. And so that's why it's so important for me to focus on protocols, not just open source cores, but protocols. So imagine each of those things being unbundled. We've got a UCAN layer, we've got a storage layer, we've got a compute layer, a Lambda layer essentially. And so people might start on Everywhere Computer and use some of our managed resources. Oh man, this is getting expensive. Great, spin up your own network of Homestar nodes. And I think this is one of the things that breaks the problem with freemium. Spend that early investor money to pay for a crap ton of resources. And then as that drives up, start putting the prices in and people are locked in. We're not going to do that. The freemium version of this is go ahead, run a couple of Homestar nodes. And that starts with something as simple as the workshop that you can join us for later today, where you run a single Homestar node on your own desktop, and it can power the functions that you need it to run. So, and we think that's a really interesting direction for, like I said, like breaking that kind of like freemium trap. There's some future things around compute to earn. Everybody's like, what's your complicated tokenomics? And I'm like, I'm actually just going to do this thing where we're going to charge people for the compute that they use. It's kind of uncontroversial. You pay EC2. As you can see, Everywhere Computer is in fact EC1. We know 1 is better than 2, so, obviously. The other part that we have to think about here is we're playing back and forth with this concept of where stuff runs. I mentioned it briefly with the low-end Android phone. So Wasm can run in client browsers on desktop and web. Again, if you went to Hannah's talk, there's this dream that in part we're heading towards that is kind of a joke, but not a joke of the Silicon Valley TV show. So with Wasm, how do we create frameworks that app developers can use to offload computation to client-owned compute when available? Every client compute cycle we run is one that doesn't need to go to pay server clouds. So how many people in the room are familiar with Figma? A bunch of hands go up. So Figma recently got bought by Adobe. And one of the reasons that Figma is used broadly is it's this multiplayer Photoshop in the cloud. Great for design, buttery smooth, works great. A ton of Figma is powered by Wasm, where a lot of that functionality is actually running in your browser. So lots of those things don't need to hit servers that ultimately would need to get paid for by Adobe. And that means also that smaller teams don't need to be Figma or Adobe sized because you're saying, no problem, we're actually just running this client side for lots of those things. We're having discussions with some relatively large players. There are teams at Intel and Google that are interested on standardizing this even more. Played around with some concepts. Maybe it's like decentralized service workers. Once you have this concept of service workers, maybe you don't even actually need to run it in the particular browser that you're on, but you can delegate it off to somewhere else to run and send the results back. If you're interested in this, I'll have links later. Leave a note in the comments. We're likely going to spin up a W3C community group to explore this kind of portable Wasm so that people can build Wasm-powered apps that automatically have compute that travels to where it needs to be. And again, at scale, you're paying for every single compute cycle to a hosted provider. So at scale, that should be this approach should save people a lot of money. Some future things. If you're going to do this in a decentralized way, we're going to need payments. Fission's approach is that all of our stuff should work at the edge and it should work in browsers everywhere, and it shouldn't require a blockchain. It can connect to different blockchain ecosystems for incentivization and payment and other things like that. Brooke and the team have done some work around IPFS-based payment channels where you could then settle to fiat or settle to a token of some kind. I know that I've caught up with the FVM team. We keep going back and forth of where we're at. We're writing in Rust. The FVM team is writing in Rust, and have been excited to talk that there's reuse of IPVM components for FVM. Again, they were part of the design process of creating the protocol, so this is not a surprise. It's just that we're coming back around and going like, yes, we're ready for this. I mentioned Kubo earlier. We use that today to bundle it. IRO tastes great with Homestar. Because it's also in Rust, unlike Kubo, we can probably even integrate it directly into Homestar or vice versa. So some of these also become toolkits. If you have interesting ideas of making public, private, or mixed networks, you could combine Homestar and IRO in interesting ways. Integration into ecosystems, app chains, L2s, mainnets. If you are interested in adding edge computation, off-chain computation to your ecosystem, let's talk. We want to empower you to run your own network of Homestars. Further language support. So right now, you can write functions in Rust to Wasm. That's a happy path. Ugo on our team has done some great work to make it easy to do JavaScript to Wasm. Python is a large community that's likely next and has some good tooling around that. Right after lunch, we have a workshop that will be in Neuchâtel. Please join us. We'll have you install Homestar. Try it for yourself. We'll gossip some receipts on the network. Knock on wood that this all works on this hotel network. And you can go to everywhere.computer and join the early access beta. Give us some info on what you want to do. We want to support you in being successful in doing that. That's the end of the talk.